Hello and welcome back to another part of the El Diablo tutorial season 2. I'm Michael and welcome back, geeks and freaks. Today we will have an exciting adventure on our hand. We will create our first AI. It will be basic and very dumb, but we will improve it in later parts. And we will create much more advanced AI logic and optimized AI logic. We will not just create this kind of AI, which I always call newbie AI, because newbies tend to start with it out when they start with the Unreal Engine. We will create also a custom AI at a later point and different kinds of AIs like beehive AI and a leader AI. Now, the first basic thing we need to do is that the AI stuff actually works, is that we add a navigation mesh volume. So if you don't have a level already, just create a default one, a new level. Just scale it up like 100, 100, and 1. And then go to the search classes and search for nav mesh bounce volume. This one here. And drag it inside the viewport. Now, as you might see, we have a green rectangle. And this is basically our navigation mesh. However, if you can't see the green visual indication, just press the key P. It will enable and disable the green square. Now, when we make it bigger, you will see that it will recalculate this green space. Now, what does a navigation mesh actually do? Well, a navigation mesh bounce volume tells the AI where it can go to. So, if I would put in a cube in here and a sphere, you will see that the volume will have cut out shapes. And in these cut out shapes, the AI is not being able to travel through. So it will avoid these gaps in the navigation bounce volume. That's how a navigation mesh bounce volume works. Because if you would have the detection of obstacles in every AI, you will get pretty nasty performance problems. And this navigation mesh bounce volume will get rid of that because it already pre-calculates where the AI can travel to. We will make it bigger. We will actually put it to 100, 100, and 10. Oops, not the sphere. Shit. We want to go we want to get the nav mesh bounce volume. So select the nav mesh bounce volume and go to scale and scale it up maybe around 50, 50, and 10. It is big enough for our AI to travel, and this is basically our test level. Test level new. So we have our prerequisites already set up. We have our navigation mesh bounce volume. So we can go to our Hollow Sentinel, which we created in the previous part. So get back to the Hollow Sentinel, get into the directory Hollow Sentinel, and open up the Hollow Sentinel blueprint. Now we end up in the event graph and our other components. Now we need to add a very special component, and it's called pawn sensing. As you can see out of the name already, pawn sensing means that it senses something. and the pawn sensing component detects, or rather checks every X seconds if something enters its vision radius or hearing radius or not. So just go up here in the Add Component tab, type in pawn sensing and select the pawn sensing component, which I already have here. Then just select the pawn sensing component and go to the viewport. You will see here a lot of radii. We have a green radius, we have a cyan radius, and we have a yellow radius. Each of them does different things. Now, when we go on the right panel, we have an AI tab here with a lot of different options. Now, the first one here is called hearing threshold, and it will only detect noises. So for example, this hearing threshold is the green, or rather this cyan sphere. We can make it bigger and smaller. Now, this will try to detect if a noise is inside the sphere and will react to it. It will fire off something called an event, which is the on-hear noise event. So every time some noise enters this hearing threshold, or this cyan sphere, it will fire off the on-hear noise, and we can create, or rather we can execute our logic behind it. Then we have something called a LOS hearing threshold. Now, the LOS hearing threshold is this big yellow sphere. If we would put it like this, only noises inside the hearing threshold will be heard. However, if we make it bigger, we will get something called a fall-off. And a fall-off happens if we have a distance between the origin location, or the source location, and the fall-off location, so the yellow sphere here. So everything, like I said, everything which is inside this being a noise will be detected from the hearing threshold. However, you can extend this hearing threshold if we use the yellow sphere, and because sound always loses power the farther it gets, or the farther it travels, for this we have this fall off. So for example, when we can 100% detect noises inside the sphere here, at a point like here, we will only have 50% chance that we can hear something. When we are here, 25% where we can hear something, and here 0% where we can hear something. So this fall off is dependent on our source location here and our yellow sphere. So this distance from here to here is basically the fall off distance. If I would make it smaller, the distance will be from this cyan sphere to this yellow sphere. So this distance is the fall off. Here the maximum noise that it will detect noise, and here the minimum where it will detect noise. So this fall off is pretty cool if you want to have some kind of an error threshold where it can hear noises or not. Okay, so the next thing we have is a sight radius, and that's the big green one here. We can make it smaller and bigger, and this is the distance, or the visual distance, where we can detect our objects we want to detect. So a higher sight radius means we can look farther into the distance and detect farther in the distance. When we make it smaller, it's the opposite. We will detect less in the distance. So the sight radius has a second option, which is down here, which is called peripheral vision angle. This angle determines how much of our viewpoint we can actually access the collisions, or rather access the checks. So a peripheral vision angle of 90 degrees means we can look forward, or we can detect things which lies forward, and we can detect things which are on the side of us. When we would change it to 45 degrees, we will only be able to detect something which is in this 45-degree angle. When we would put it to 180, our enemy, or rather our AI, will basically get eyes in the back of our heads. That's creepy, but it will be able to cheat and actually see 180 degrees. So it will be able to detect everything. Most of the time we keep it at 90. And the next thing we have here is called the sensing interval. The sensing interval is very important for performance and detection reasons. First off, the sensing interval is measured in seconds, and right now, every 0.5 seconds, the pawn sensing will try to check its surroundings. So if we would increase it to 1 second, the pawn sensing component will try to check every 1 second, or in every 1 second intervals, if something enters our pawn sensing component. When we make it lower, for example 0.1 seconds, it will check every 0.1 seconds if something enters here. Now if you might see, the more we check in an interval, or the more often we check in an interval, the higher the performance consumption, because we call multiple times. However, if you change it back to, for example, 2, we will increase the performance because we don't check as often as on 0.1 seconds. However, our collision, or rather our detection, will be less accurate because we will not check as often as we did with 0.1 seconds. So our enemy will respond later. That way we always need to somehow get a sweet spot where it can check and where it can react. The next thing is the hearing max sound age. And you might think, what the fuck has age to do with sound? Now, it is not the conventional sense of age, but sound ages also. For example, like you might know or not know, sound travels in the air. And the sound is always the strongest on the origin location. So if you speak to a person in front of you, he will be able to hear you nice, loud and clearly. However, if he moves around 20 or 50 meters away, you will not be able to hear him as loud and clearly as before. So because the sound age is the distance it has already traveled from the origin point to another point. So the longer the sound travels, the less the volume will be or will get, and the less volume will actually receive the end of the distance. That's what the sound edge does. So if you would decrease basically the sound edge, it will have a higher hearing, or it will have a higher error threshold that you will miss some sounds. So changing this value means that you will have more errors, or rather more missed noises. So it will not execute the on-hear noise as often or as accurate as it normally is when we put it on 1. However, we will not use the noise feature because it's outside of a hack and slash game, and yeah, we don't need it in our scenario. However, this is able to do it, but if you want to actually use audio, or rather noise events and noise feedback, I would recommend you to use AI perception and not the pawn sensing component, because as far as I know, the pawn sensing component is kind of buggy in that regard. Okay, so this is the Hearing Max Sound Edge. Then we have the enable sensing updates. This should be enabled when we want to use this this component, so it actually checks for things. Then we have an option called only sense players. If the component only needs to check for players, you should enable this. However, if you want to check it for other actors, or rather for other things, like for example companions and such, you will need to disable this one here. Then we have something called see pawns, and this just asks if we want to visually try to trace any kind of actor which tries to get into our sphere. We want to use the visual indication, or rather the visual element of it, so we have it enabled, the see pawns checkbox. Then we have here noises, which will disable, but this is responsible if we want to have here if we want to listen to noises or not. This is what the pawn sensing itself does. So when we select the pawn sensing again, we will go to the plus sign on the unsee pawn, select it, and we will get this note here. This will fire off our chain of execution after here, and we will use it for our basic AI operations. Okay, now I will get some breath, and then I will continue. So, we have different AI nodes to our disposal. So I will already add some of them. Right click and type in AI simple. So we will use the simple move to location. Then we will right click and search for AI. We will use the AI move to. The last thing we need to add is the AI move to, the move to location or actor. These three AI nodes are different kind of beasts, as you might see already with the options. The first one is called the simple move to location, and it has two options. It wants to have a controller and it wants to have a goal, so a destination. However, we don't have a controller. We could also say, okay, we get the get player controller and plug it in here. However, this will not work. It doesn't ask us about the player controller. It wants to have our AI controller. But how do we get the AI controller? We need to get it from our pawn itself. So we right click, search for get AI controller, and select the get AI controller. Now, as you might notice, that's a weird get node. Normally, you don't have executions here, or rather execution pins here. Normally, they are not there. For example, if I search for get what location, you will not have any execution pin here. But this get node needs to be executed so we can actually get the current AI controller. We have two options here, controlled actor and return value. The controlled actor is our enemy itself. So we just drag out here and type in self. So we get a reference of our enemy blueprint. Now, we could actually use the on-C pawn sensing to get our AI controller. However, that's very bad. That's very bad programming. Because we don't need to get the AI controller every 2 seconds or 0.5 seconds or whatever we have in the interval. The best practice is to get the AI controller up here and set it at the event begin play. That way, when the enemy is being spawned, it will automatically get the AI controller. And to get a reference for it, so we can always go back and access the AI controller, we will drag out from the return value and select promote to variable. We will call it AI reference or AI controller reference. Then we can always access the controller if we want to, and it's always the current and active controller. So we have the controller right now, so you will get the AI controller reference on the left panel here, drag it in, select get, and put it into the controller. Congratulations, you already did one step towards new by AI. The second thing is goal. Now we could say, okay, it needs to go to a certain point, for example, a random point in a radius, or it should just follow our player. Right now we will just get our player location so it can follow us. I right click, type in get player character, and out of the return value we would drag out and search for get actor location and put it in here. We will put it on the on-C pawn and then we will see what happens. So we will drag some of them in here, some of our enemies, and press play. Whoops, I forgot about it. Every time we have a new level, we need to select a game mode. And we have our El Diablo game mode, so we have it fixed now. And then we press play. Now you will see nothing will happen, but that's because we didn't enter the sphere radius of our sentinels. So when we enter the sphere radius, or rather the radius of the pawn sensing, it will go to the location. However, it will not follow me, and that's because it only saves the last location. For example, this. And that's why a high pawn sensing value can lead to problems, because they won't chase you anymore. However, you can't just make it 0.1 seconds, or you will basically wreck the CPU and the performance will go down the drain. So the simple move to location is rather limited in its use. So we go to the next one, the AI move to. That's basically a real upgrade to the simple move to location node. We have different options here. Excuse me. We have an execution pin, like this one too. We have a pawn reference, which we have a destination, we have a target actor, we have an acceptance radius, and a stop on overlap. Then we have a normal execution output. Then we have an on success execution pin and an on fail execution pin. Now in the pawn, it wants to have a pawn reference. However, down here we want to have a controller. That's where AI move to actually shines. We can just drag out from the pawn return pin, and we can type in self. it doesn't need an AI controller, and we don't need to get an AI controller. It only needs a reference to the blueprint itself, and we'll get the AI controller itself. It will just, yeah, it is basically just a difference between this one here and this one here. So this can only be referenced by the pawn itself, which can be handy, for example, if you can't get access to a controller, or if you want to have an AI which doesn't listen to a certain type of controller, or if you have a convoluted system or a tedious system where you just can't get the controller out of. So that's where AI move to shines. The next thing is a destination. It's the same thing as the simple move to location. So we will try to do the same thing, just plug in the get actor location in here, then connect it with the AI move to the unsee pawn, and try it out. Like you can see, it does the same thing. However, we have something called a target actor pin. We can just disconnect the destination pin, and here we can specify an actor which it needs to follow. So it will not just save the last destination, it will go and follow the target actor until it reaches the target actor. So the target actor is in our case the player character. So we connect the return value to the target actor, and when we then press play, it will try to follow us until it reaches us. See? However, you see there's not much between, or not much space or distance between us. So they are kind of trying to collide into my sphere or into my collision. That's bad. That's very bad. Especially if you have a lot of enemies which surrounds you and then you get stuck. It's basically massive hugging. And you will be hugged to death. So to avoid that, we have something called an acceptance radius. So an acceptance radius means how far should the actor be from the AI. When I put it up to 200, it will stop at a distance of 200 to follow me. For example, now they stop before they actually reach me. So that's the acceptance radius. Why is the acceptance radius so important? Because if you want to have attack animations, you normally don't want to have them collide into you, because it will get weird errors. So with that way, you can set the spacing between the attack radius and the follow radius. For example, if you have an acceptance radius of 200, it will get to the acceptance radius of 200, stop, and when you have then attack logic, it will execute the attack logic. That way you don't need to have an extra sphere checking for something. So it's a pretty neat feature. Then we have an option called stop on overlap. And well, it stops when it overlaps with a collision, or rather with an actor. So if you enable it, it will stop when we reach an actor, or rather when we collide with an actor. On the other side, we have an execution pin. So this is more like a gate. You execute something here, and then you can immediately execute something different here. Then we have an unsuccess execution pin. And this one will only fire when it reached the destination or our actor. So if you, for example, like the previous example, if we want to have attack logic and when it reaches us, it needs to attack us, we can put it after unsuccess. So you can fire off your weapons events or your attack functions after this one here. Then we have the onFail function, which is also very important. For example, if it can't get rid of something, or rather if it can't get past something, it will fire off the onFail event. And with this onFail event, you can, for example, execute different functions or a different logic, so it might be able to avoid certain things or get past certain things because because it has a different kind of command which you execute after on this onFail event. So yeah, that's a pretty cool node. But there's always an upgrade. We have something, the non-plus ultra, called move to location or actor. So the difference here is, again, we need a controller. So we need our AI controller reference. We will connect them, and then we have a go location. The go location, whoops, let's get the last node again. The go location is the same as the destination of the AI move to. The goal actor is the same as the target actor we can specify here. The acceptance radius is the same as the acceptance radius down here. But then we have two options again. Stop on overlap, which is on default, yes or no. So it's the same as the checkbox down here, just that we have the default option. Yes means checked, no means unchecked. Then we have a real cool thing here. This is called accept partial path, and it's on default. We can set it to default, yes or no. Now to explain to you better what it means to have an accept partial path is, for example, let me create some target points. We have 3 target points here. We have the distance from here to we have the A, B and C letters here. So if you want to go, for example, in AI, if it wants to go from A to C, it will calculate the distance between A and C and create some kind of a path. It always needs to calculate a path or take a certain path. So that naturally drains performance. So if we want to go from A to C, the AI will get it back, will calculate the distance between A and C, and will create a path. However, if we use the accept partial path, it will not always calculate the full path. If you just want to go from B to C, and not from A to C, but just from B to C, we can use the accept partial path to calculate the distance. So the distance from B to C will only be calculated. So the path calculation cost to create some kind of a way will be lowered and will be halved. So we can save performance with accept partial path, and I would recommend setting it to yes. Then we have something called use pathfinding. And this basically means, do we use a navigation mesh with it, in conjunction with it? And we want to use pathfinding, so yes, we will keep it. Then we have log AI logic. And this can also save performance, because normally if you execute the move to location or actor node, you will not be able to modify this one here. You can't modify the path anymore, you can't modify the location anymore, or the goal actor or anything like that. This will just execute until it's done. Log AI logic prevents any modification into this one here. However, you can deselect it and you can modify your options you have in here. However, I would always recommend checking it because it doesn't make much sense to have it being modified, because it's mostly it's mostly not used or it's mostly not needed to do it or to modify this. If you want to modify something, you can actually rerun the whole node and you will get just better performance out of it. Now, the next thing is we have an execution pin here where we can have things like other chains of commands. Then we have a really cool thing here. It's called an async task proxy. Now I get a little bit more technical. Every game mechanic or every game you program is normally run on something called the game thread. This is a dedicated thread for the game mechanics itself, for the actually one path on the CPU, which handles logic from the game itself. Now, AI normally also runs on a game thread. However, we can use async task proxies to circumvent it. We can actually tell the AI to not run on the game thread, but on a separate thread on the CPU, which will free up much more performance because it doesn't block up the game thread, or it doesn't block the game thread. If you want to have more information about the async task proxy, how to set it up and make C++ function, which you can access in the blueprints, please go to the docs. It's pretty much well explained. There are also wiki tutorials out there how to set something like this up, but I just want to tell you that this exists. So if you want to have AI run on a separate thread and you want to increase the performance if you have a lot of AI stuff running around, and it is recommended to use this one here. Then we have an onRequest failed, which is the same like the onFail event down here, just that they switch position. onRequest failed is here on the first option, and onSuccess execution pin is on the AI move to first option. So they just switch position. But the onRequest failed is the same as the onFailed, and the onMove finished is the same as the onSuccess. So the rest is the same. So this is a thing we will actually use. However, we will also use this one here. We can always use things in conjunction, and that's the beauty of the Unreal Engine. You don't have a direct path, or you don't have just one path to do things. You can make it in a different variety of ways. Okay. So these are the three options we have, but we will use the move to location or actor and AI move to. Now we can actually delete these, but like you have seen before, the AI does what we told them to do, and in the next part we will get much more in depth with it, with the same AI logic, but we will just outsource it a little bit, so we have some kind of a crowd controller, because we create a hack and slash action RPG. And when you look at Diablo, Torchlight, Grim Dawn and such, you will always see that they're kind of crowd controllers and doesn't try to get to a position as phonetically as normally the pawn sensing component, for example. Because when you use the pawn sensing, you will always see that all of the enemies try to get to you, but they can't. They block each other, and it gets real weird, and they can't really reach you, and they will block itself, they will block themselves, and it's just something you don't see in these professional products. So we need to specify, or rather we need to have some kind of a crowd controller which tells them where they need to travel to, so we don't get this weird thing. Okay, this was the first real technical part of the AI, and yeah, I hope you have a good day. I wish you a wonderful good day, a good evening, or whatever, and I hopefully see you next time. So goodbye.